Logarithmic equations so this is where I'm going to have an equation with logarithms in it, and x's, usually taking the logarithm of x, something that I don't know. So these are my steps that I'm going to do to solve these. Solve logarithmic equations. So first we need to isolate the logarithm part. So get the logarithm part alone, if we can. And then my next step, this is to raise both sides with a base equal to the log base, the logarithmic base, having both sides, having the equation now as the exponents. So we're going to raise both sides with whatever my original equation was. Now those are going to become the exponents with a base of whatever I choose. And then step 3 would be simplify and solve. Simplify and solve. And then step 4, I'm going to start this, is to check. And not just like, okay, we should check it, but we don't always. We have to check these. Because if we think about logarithms, the basic log x graph looks something like this. So the domain of this is just from 0 to infinity. So there's going to be x's that we may get that as an answer, but it's not part of the domain. And you know, once things are shifted around, it might not necessarily be 0 infinity. I'm just showing that as an example of why we always need to check, because there's a lot of times x's that don't work. Okay, so let's do a couple of examples. So first example, log 5x equals 2. Log 5x equals 2. So in this one, the logarithm part is already by itself. I don't have to do anything to isolate it because I'm taking log of 5x. Right now there's no base, but so if we don't see something, remember that we assume it's a base 10. Log base 10 of 5x equals 2. So now step 2 said raise both sides with a base equal to the base of the logarithm, with the two sides being now the exponents. So what my next step is going to look like, I'm going to raise both sides with a base of 10. So I have 10 to the log base 10 5x equals 10 squared. So I'm raising both sides with a base of 10. Now the left side, that's my exponent. 2 is my exponent on the right side. So what's going to happen is here, 10 to the log base 10, this is going to cancel out. So the 10 to the log base 10, that's going to drop out, and I'm just left with 5x. And then 10 squared, I'll simplify that, that's 100. Divide by 5, and I get x equals 20. Now let's do a check. So this is my check. So log base 10 of 5 times 20, that's log base 10 of 100. And yep, log base 10 of 100, 100 is 10 squared, that would be 2. So I know it checks out. Okay, so this is a valid answer, x equals 20. Okay, how about natural log x minus natural log parentheses x minus 4 equals natural log of 3. Okay, so now this one, for step 1, I'm going to have a little work to do. I'm saying isolate the natural log parts. So in this case, I've got 2 natural logs, but I should be able to put these together using the quotient rule. If I have a subtraction between 2 logarithms, I can write this as the quotient of the first one over the second one, whatever one's after the minus. So this is the same, natural log of x over x minus 4 equals natural log 3. So now this side I've got just a natural log, this side I've got just a natural log. So now I'm going to raise both sides with a base equal to whatever the logarithm base is. So a natural log, remember natural log of x, this is the same as log base e of x. So in this case I'm going to raise both sides with a base of e. Just going to kind of throw that into my equation. So that, what's going to happen is e to the natural log is going to cancel out. So I'm just left with x over x minus 4 equals 3. And now from here, I want to get rid of this fraction, so let's multiply both sides by x minus 4. We'll cancel out on the left side. Right side, I'm going to do some distributing, 3x minus 12. So now let's bring the 3x over. So negative 2x equals negative 12. So x equals 6. Okay, now remember we have to always check these. So let's do a check. Check that x equals 6 is going to work. So natural log 6 minus natural log of 6 minus 4 is 2. Is that natural log of 3? And I mean, at this point I would say probably just plug this into your calculator. Natural log 6 minus natural log 2. It should equal whatever natural log of 3 is in decimal form as well. Okay, I mean, you could go another step, use the quotient rule. This is natural log 3, so yes, it's going to work out. Natural log 3 is natural log 3, or use your calculator, either way. Okay, let's do one more. One more example. How about log x plus log parenthesis x minus 9 equals 1. So kind of similar, it starts off similar to the last one where I can put these together using one of the properties. In this case it's multiplied. X times x minus 9 equals 1. So I'm going to raise both sides with a base of, in this case, again, I don't see a base, so it is 10. 10 is my base. Now, on the left side, the log is going to cancel out. I'll be left with x times x minus 9. And then on the right side, 10 to the 1 power is 10. So when I'm going to distribute this, I'm going to have x squared minus 9x. So, equals 10. So I've got an x squared. So usually to solve these, I have to set it equal to 0. I'm going to move the 10 over. X squared minus 9x minus 10 equals 0. And let's see if I can factor this. So 10. Looking at that, this is a 9. I mean, 5 and 2 is not going to work, but how about 10 and 1? If I have a minus 10 and a plus 1, outer is plus 1x, inner minus 10x to get my minus 9x, last is minus 10. So that means I get x equals 10 and x equals negative 1. Now here, let's check these out. A lot of times when I have two of them, sometimes they both work out, but a lot of times they don't both work out. So let's check out 10 first. Log 10 plus log of 10 minus 9 is 1. Is that 1? Well, log of 10 is 1. That's log base 10 of 10. 10 to the 1 power. So that's 1. Log of 1, no matter what the base is, it's always 0. So yep, 1 plus 0 is 1. That checks out. How about the negative 1? Log negative 1 plus log negative 10 equals 1. So already I have a problem here. I can't take the logarithm of a negative. So at this point, this is undefined. If you plug this in your calculator, you're going to get an error message. Or think about the graph like we talked about. I can't take x is negative 1 over here. I can't take the logarithm of that. I'm not going to get a y value. So only, this one doesn't work out, only x equals 10.